Hey everybody, this is Mrs. Johnson. I had a couple questions about WebAssign in section 5.1, so I just wanted to show you we usually have a program that I put on your calculator, but we can also use some websites here. In the week 14 folder, there are web links down here, and there's a bunch of different demonstrations. I'm just going to show you two of them today. They're really pretty cool, but I'm just to get you going on your homework. Um, This is showing you the area underneath the curve, or how to show the different rectangles. I'm going to use these last two to show you different ways that we could find the LRAM, the RRAM, and the MRAM on this thing called GeoGebra, which is a really cool site. This particular one, you can put in a function here and then click on the LRAM and you can see. So this, here's your X1 says where you're going to start. This is your X2, which is where you're going to end. And this slider here goes how many rectangles you want to draw. You can see you can slide it back and forth. This gives you the LRAM. This gives you, we can unclick that and put the RRAM. Unclick that and put the MRAM. You can see them there, or you can actually see all three together. And they actually calculate those values for you. So what I want to show you is in WebAssign, this is WebAssign 5.1, Rami was asking me about question 4 here. It said to use a calculator or computer to do these. So it's asking you to use, if you look, compute the sum of the areas of approximating rectangles of equal subintervals and right endpoints using n equals 10, 30, 50, and 100. So it says 4 cosine of x from 0 to pi over 2. Now this particular function that we have here, let me get rid of this one right here, this one will work perfectly for us, but I'm going to show you how you would put this in here. If you had a function, you would say 4 cosine of x, and you can see that the function would nicely graph. You can see that we can grab this and look, the function would nicely graph this. I can actually zoom in a little bit too here. So we're only looking at the graph. I'm going to zoom out. Or maybe not. So these tools over here actually will help you zoom in and out. You can see I'm going to zoom out a little bit here and then move my graphic again. Here's my graphic. Okay, so here's my cosine curve, 4 cosine of x. Now, again, in our homework, we want to go from 0 to pi on 2. Now, the problem with this particular one here is that if I put in my function and I put my slider, I want to go from 0 to pi over 2, I can't actually put pi over 2 in here. Remember, pi over 2 is about 1.57, and this will bring me to like 1.5 or so. So I can go, it's only going up 1.5, 1.6. Now, if I want the RRAM, you can see that it'll calculate it here, but notice it's not quite getting to the point I want. It's not quite getting to pi over 2, and if I use 1.5, it's not also getting there to the point I want. So if I put in this into my homework assignment, go back, we'll see what that was. That was 3.671, and I hit submit my answer. It's not quite getting there because of the fact I can't be too exact. But this is a really cool, for if we didn't have functions in terms of pi, this would actually be a pretty good, cool thing where I could put any other function in here. And notice if I went back to the function they gave me, this was a pretty cool calculator to calculate the LRAM, RRAM, or MRAM. So depending on the function. So there's another link in the Weblinks page, this one right here, it's called the definite integral. And this one is actually can get us more exact because we can type in the upper and lower bounds. This is called the definite integral illustrator. And again, let's show it how it works. We would type in what the function is. This is 4 cosine of x was the function we had. We wanted to go from a lower bound of 0 to an upper bound of pi divided by 2. Notice I just put in pi for pi and hit enter. And notice now that you can see this is the curve and it does the number of rectangles. Here's my slider for the number of rectangles. But again, the homework assignment, remember, it asked me to compute the sum of the areas approximating rectangles with right endpoints using 10 rectangles, then 30, then 50, and so forth. So let's use the right endpoints, and I want to do 10 rectangles. So let's do 10 rectangles. There we go. And you can see here's the calculation of it right here. And then we go back to our homework and we put in 3.676 and submit our answer. And now it's giving us the correct answer. So you can see that this is a pretty cool calculator. It's a way to calculate the different, in this case, the right-handed rectangular approximation method doing 10 rectangles. Now the next one they asked us to do was 30 rectangles. So let me get here to 30. And again, I'm just using the right arrow once I get close. So for 30, it should be 3.8944. 3.8944. And notice that's giving me a correct answer. And now I wanted to go to 50 rectangles. So let's go to 50 rectangles. 50 rectangles would be 3.9368. 3.9368. And that's correct. And I want you to notice that you can see that the more rectangles I have here, I can actually zoom in a little bit here. It's really pretty, it's almost, you can hardly see how there's so many rectangles there. And then the last one was to use 100 rectangles. So I think we can go up to at least 100 here. So here's 100 rectangles. 100 rectangles would be 3.9685. 3.9685. If you notice, this is getting closer and closer. It looks like it's getting really close. We're guessing 4. And that's exactly it. So this is the way you could do this particular problem using this definite integral illustrator as your calculation method for the WebAssign. Now, there are other web links in here that are also pretty cool to look at if you want to look at them. They're just different ways that we can, this was just to illustrate how these rectangular approximations work. And this is just to show you a curve and to show you that obviously the more rectangles we draw, right? The more rectangles we draw, the more accurate our area underneath the curve is going to be. And that's our whole concept here of using what's called this rectangular approximation method. There's another one here that has a demo for RAMS also. This one is also, you can put in the function. The only problem with this one is it has a slider. It only goes up to 20 rectangles. You can only go to 20 rectangles here. But we could change the function if we wanted to. This is a natural log function. But if I put in 4 cosine of x here, you can see that it does give me, and I can go from 0 to pi divided by 2, which is good over here. You can actually see the curve looks like this, right? But my problem is I don't have enough rectangles here. I could use it for the 10 rectangles, right? We could use it for 10 rectangles, but I could only go up to 20 in this particular illustration. So I couldn't find the other answers. But these are all web links that are cool web links to look at, these 4 web links to demonstrate the rectangular approximations. Hope that helps.